Welcome to AI Frontiers. Today's episode is titled, Robot Swarms. AI's Seamless Symphonies, synthesizing 17 papers from August 27, 2025. Breakthroughs in robotics and AI integration are explored, highlighting multi-robot coordination, skill transfer, and digital twins. This is presented by AI Frontiers. This presentation unpacks innovations in robotics. A dive is taken into how AI transforms robot chaos into coordinated efficiency. Themes, key findings, and 3 pivotal studies are explored. Robots learning from humans and reconstructing worlds from photos are imagined. This narrative sparks curiosity for enthusiasts and experts alike, building toward future directions and a call to action. The field of computer science, robotics blends AI, control theory, and vision to create machines that sense and act in the real world. Real-world challenges like labor shortages and hazardous tasks are addressed, with key applications in self-driving cars, surgical aids, and precision agriculture. Hurdles in unpredictable environments are faced, bridging simulation to reality. These papers highlight growth in adaptive, integrated robotic systems. One key research theme is multi-robot coordination, focusing on scalable planning for robot fleets. Large groups of robots are coordinated without collisions. Liang et al. Employed diffusion models for up to 100 robots in tight spaces, emphasizing efficient paths ideal for warehouses or rescue operations. Diffusion models are introduced, where AI generates smooth trajectories from noisy data. This connects to safety in dynamic, crowded environments. The theme of multi-robot coordination continues with enhancements in collaboration and safety. Planning is built upon with human-aware navigation to predict risks. Semantic graphs are integrated for context-aware accident avoidance. Evidence comes from papers on crowd prediction, which reduce navigation times. Graph-based modeling is a technical concept that structures data for interpretable decisions. This paves the way for robots to serve as polite partners in shared spaces. Another pivotal research theme is human-to-robot skill transfer, centered on dexterous manipulation from human data. Complex tasks are taught to robots via human demonstrations. Yuan et al. Enable bimanual grasping on mobile robots from videos, closing the sim-to-real gap for tasks like puzzle assembly and clutter. Reinforcement learning is explained, where robots learn optimal actions through trial rewards. This boosts adaptability for home or hospital assistants. A final dominant research theme is 3D reconstruction and digital twins, using sparse data for real-world models. Virtual replicas are built from minimal inputs. Chu et al. Reconstruct apple trees from single photos for agriculture, employing generative AI to fill data gaps and enable robotic planning. Neural fields are a technical concept that represent 3D shapes continuously for accuracy. This applies to farming simulations and environmental monitoring. Key findings across the papers reveal critical insights. Scalable planning handles 100 robots, improving success rates as shown by Liang et al. Skill transfer boosts dexterous tasks by 40% via human data, according to Yuan et al. 3D reconstruction achieves results 360 times faster, matching accuracy for digital twins by Chu et al. Crowd navigation cuts times by 26%, enhancing safety in human spaces. Bio-inspired designs reduce energy, enabling longer missions. Methodologies are synthesized from common approaches in these works. Sampling-based planning builds optimal paths in complex spaces. Reinforcement learning adapts via rewards, with hierarchical methods for long tasks. Vision language models fuse senses for intuitive, multi-step control. Diffusion models generate creative data, efficient for sparse inputs. Real-2 sim pipelines bridge simulations to reality, balancing scalability. The first selected paper is by Liang et al., titled, Discrete Guided Diffusion for Scalable and Safe Multi-Robot Motion Planning. It is selected for novelty in scaling to 100 robots, representing the coordination theme. The objective involves hybrid planning for smooth, collision-free paths in crowds. Methods include discrete guides that refine diffusion models for efficiency. Findings show higher success rates and faster planning in simulations. Significance lies in enabling real-world fleets, transformative for logistics. The second selected paper is by Yuan et al., titled, Hermes, Human-to-Robot Embodied Learning from Multi-Source Motion Data for Mobile Dexterous Manipulation. It is chosen for impact in sim-to-real transfer, key to the skill theme. The objective is to teach robots dexterous tasks from diverse human data. Methods involve end-to-end reinforcement learning with depth-based augmentation. Findings demonstrate robust generalization in cluttered, mobile scenarios. Significance advances home assistance, inspired by human intuition. The third selected paper is by Chu et al., titled, DATR, Diffusion-Based 3D Apple Tree Reconstruction Framework with Sparse-View. It is picked for representativeness in digital twins, with a novel agriculture application. The objective is to create accurate 3D models from single photos despite occlusions. Methods feature a two-stage process with diffusion and neural fields on synthetics. Findings match scanner accuracy, with processing 360 times faster. Significance democratizes farming tech, aiding robotic interventions. Future directions in robotics research point toward bio-hybrid systems for enhanced sensing and adaptability. Edge AI is pursued for real-time decisions, reducing cloud dependency. Sim-to-real gaps and ethical human-robot interactions are addressed. Standardized benchmarks for multi-robot collaboration are expected. Quantum computing is integrated for ultra-fast planning in complex scenarios. This synthesis and review were created using AI tools, including GPT-Grok with model Grok 40709. TTS synthesis was performed using Google, and image generation also using Google. The synthesized content underwent review by a human expert. It is important to acknowledge that some oversights may still exist. All references are provided. Subscribe to the YouTube channel for more AI and robotics insights. The channel is titled, AI Frontiers. Hit subscribe and turn on notifications to stay updated. Thoughts on robot breakthroughs can be shared in the comments. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.